In this tutorial, we have a nice, beautiful question on logarithm that has to do with simplification. Trust you me, it's a very simple and easy problem. Now we have to simplify 3 log to the base 6 of the argument 9, log to the base 6 of the argument 12, log to the base 6 of the argument 64, minus log to the base 6 of the argument 72. As you can see this entire expression, the only odd man here is this first guy. Now, from the power rule, if any number is at the back of a logarithm, that number goes to the exponent of the antilog or argument. So we can rewrite this to be log to base 6 of 9 to the power of 3 plus log to base 6 of the argument 12 plus log to base 6 of the argument 64 minus log to base 6 of the argument 72. Now, from the multiplication slash addition law of logarithm and the division slash subtraction law of logarithm, we can simplify this. It's a one-step solution. Now, from the multiplication law, if we recall, if we have logarithm to the base of a of the argument b multiply c. So we can write this as logarithm to the base of a of the argument b plus logarithm to the base of a of the argument c. Similarly, for the division rule, if I have log to the base of a of the argument b divided by c, I can write this as log to the base of a of the argument b minus log to the base of a of the argument c. That's the reason why I coin it the multiplication slash addition, division slash subtraction. So you can see that if the logarithm are added together, we are going to take the multiplication of the arguments. And if they are dividing each other, we are going to, if they are subtracting each other from what you have on the right side here, we are going to take the division of the argument. So with these two laws, we can simplify this. Now, the minus here from what I just said is the division. So what we are going to do is to open a big parenthesis. So what we are going to be having is 9 to the power of 3 times 12 times 64 divided by 72. You can see how interesting this problem is. Since we are not using table or calculator, it is rather difficult for somebody with a low IQ to multiply and divide this out. But the best approach is to use indices. Now, 9 is 3 squared, so I can write log to base 6. I'll still open a parenthesis. This becomes 3 squared to the power of 3. That becomes 3, 2 times 3, which is 6. Now, 12 is 3 times 4. And 4 is a base of 2, which is 2 to the power of 2. So I can write this as 3 to the power of 1 times 2 to the power of 2, which is 12. Then 64 can be expressed in base 2, which is 2 to the power of 6. Now, 72 is 8 times 9, and 8 is 2 to the power of 3. 9 is 3 to the power of 2. So with this, we are home and dry. What we are going to use here is the multiplication and the quotient rule of indices. As you can see, these two bases of 3 are multiplying each other. So we add the powers of the exponents. The same thing we do for these two guys. So we are going to have log to the base of 6, 3 to the power of 7, times 2 to the power of 8 divided by 2 to the power of 3 times 3 to the power of 2. So at this level, we have to align these guys. 2 to the power of 8 can divide 2 to the power of 3 because they have the same basis. 3 to the power of 7 can divide 3 to the power of 2 because they have the same basis. So if we invoke the division rule, It means we have to subtract the powers. Now, I can write this to become log to the base of 6. Let me start with 2 first. 2 to the power of 8 divided 2 to the power of 3. So if I subtract 3 from 8, I will have 5. That becomes 2 to the power of 5. The same thing here. 3 to the power of 7 divided by 3 to the power of 2. We have to subtract the powers. 7 minus 2 is 5. That becomes 3 to the power of 5. Now, what we are going to do here is to go back to the fundamental law of indices that is hidden. I call it the reverse product rule. What this rule says is this: if you have two or more numbers of different bases, please listen to this carefully. If you have two or more numbers or letters of different bases and they are having the same power, you multiply the bases. An example is this: if I have a to the power of n times b to the power of n times c to the power of n, it could be 4, 5, or more. Because the powers are the same, I will multiply the bases. A times b times c all to the power of n. I call this the reverse product rule of indices. Very interesting problem indeed. Now, it is the same thing we are going to do here. Because the exponents or the powers are the same here, I will multiply the two bases. So 2 times 3 is 6. What we are going to have is log to the base of 6, then 6 to the power of what? 5. So it's a very vital tool, the reverse product rule of indices. Now, as we can see, this is, okay, let me write this well. This is the argument of 6 to the power of 5. From the power rule, this power will fall back to the back of the log. So I will now have 5 log to the base of 6 of the argument of 6. And finally, when you have log to a base of the same argument, the answer is 1. The base and the argument, whether a number or a letter. So log to the 6 of the argument 6 is 1. So we are left with 5 as the answer. You can see it's an interesting question. Please continue to support us by liking, watching, and sharing our videos. You can also give this video a thumbs up and share with your colleagues. Thanks.